Hey, welcome to the Explainer. Today, we're diving into something pretty wild. A paper that takes this ancient, almost mystical idea and tries to prove it with straight-up math. So how on earth did they do that? Let's find out. It all starts with this really profound statement from Eastern philosophy. My mind is the universe. For centuries, people have seen this as a beautiful, poetic way to talk about the connection between our inner world and, well, everything out there. But what if it's not just poetry? The paper we're looking at today asks a pretty mind-bending question. What if this isn't a metaphor at all? What if it's a statement that's actually provably true? Is this philosophy or is it physics? All right, so here's our game plan for cracking this riddle. First, we'll look at the ancient idea itself. Then, we need to define our terms. What do we even mean by the universe and the mind in a mathematical sense? After that, we'll get to the heart of it, the equation that supposedly links them together. And finally, we'll ask the big question, why should we even care? Okay, let's kick things off with Section 1, the ancient idea. You see, the big hurdle here has always been bridging two totally different worlds. How do you take this deep philosophical concept, this idea of unity between yourself and the cosmos, and translate it into the cold, hard language of mathematical physics? And that brings us to the paper's central claim, which is, well, it's incredibly bold. It's trying to build a literal mathematical bridge. The core idea is that the structure of the mind can become mathematically identical to the structure of the universe. I mean, think about that. Not just similar, not just a nice analogy, but identical. Now, to solve a puzzle this massive, we have to define our pieces first. So let's start with the first half of the riddle. When this paper talks about the universe, what are they really talking about? So the paper gives us two ways to look at the universe. On the one hand, you have what it calls the geometric universe. This is the one we're all familiar with, right? Space-time, cause and effect, things happening. It's like the 3D world map you see when you're playing a video game. But then, on the other hand, you have the matrix universe. This view sees the universe as just data, pure information from experiments, like the actual source code that makes that video game run. Okay, but for these two different views to actually describe the same thing, all their clocks have to take at the same rate. So a really crucial step here is what the paper calls a unified timescale. It's like creating a master clock that syncs up everything, the time from particle collisions, the time flowing through space-time geometry, and even the observer's own sense of time, all into one single consistent timeline. All right, so we've got a mathematical handle on the universe. Now, we've got to tackle the other, maybe even trickier half of the mystery. How in the world do you define the mind in a way that you can actually do math on it? And this is super important. When the paper says mind, it's not talking about your physical, biological brain. Nope. Here, the mind is an abstract idea. It's a mathematical space. Basically, a collection of all the possible ways you could model the universe. Just think of it like an internal map of reality that an observer is constantly drawing and redrawing. And this map isn't just sitting there. It's alive. It's constantly learning. Here's how it works. You start with a really blurry map. That's your initial guess about how the universe works. Then you make an observation. You go out and collect some data from that matrix universe we talked about. And finally, you use that new information to update your map, making it sharper and more accurate. This whole process, by the way, has a name in statistics. It's called Bayesian updating. So the big argument here is that if you just keep doing this, observing and updating, the theory says your internal map, your mind, is guaranteed to get closer and closer to the real structure of the universe. It literally learns reality from the ground up. And this is where it all clicks into place. We now have the two main pieces of our puzzle, a mathematical way to describe the universe and a mathematical way to describe the mind. So it's finally time to see how they fit together. Which brings us right to the million-dollar question. So what is the connection between the universe's fundamental code and the mind's ever-improving map? And here it is, the big reveal. The paper's main theorem claims that the geometric structure of the mind's information map becomes identical to the geometric structure of the universe itself. Let that sink in. Not just similar, not a metaphor. Mathematically, they become the same thing. This equation right here is the heart of it all. The key word you need to know is isometric. In math, that means these two things, one describing the physical universe, the other describing the mind's information space, become completely indistinguishable. They're just two different labels for the exact same underlying object. Okay, I know what you're probably thinking. This sounds incredibly abstract, right? Like, is this just a bunch of math on a page? So, why does any of this actually matter? Let's talk about how this isn't just a philosophical game, but a framework with ideas you could actually go out and test. And believe it or not, this theory isn't just floating in the clouds. The paper actually shows how it works perfectly in a super simplified toy model universe. But get this, it also proposes an actual engineering setup. You could use electromagnetic networks to build a tiny matrix universe in a lab. And then you could use an AI as the observer to see if it can learn the rules of that lab universe, putting the whole theory to the test. When you boil it all down, the crucial takeaway is this. The theory completely changes how we think about the relationship between ourselves and the world. The observer and the observed aren't two separate things. They're two sides of the same coin, linked together by the flow of information and that unified clock. Which leaves us with one last really big question to think about. If the mathematical structure of your mind can, at least in principle, perfectly mirror the mathematical structure of the entire universe, what does that really tell us about the nature of reality itself?